Hello everybody. This is your notes video on special right triangles. So this one hopefully is going to be pretty short. This is more like a bonus topic. If you're in MYP, I will go over this with you a little bit. There's a question or two like this on your practice for this section. But this is just like another tool in your tool belt, in your right triangle tool belt. Okay, so let's jump into it. So there are two different types of special right triangles. Okay, and the reason that they are special is because they have ratios between all of their sides, which makes solving problems with those types of triangles a little bit easier, a little bit faster, right? Rather than having to plug everything into the Pythagorean theorem and solve, you can, if you know the ratios, work with the ratios and the side lengths that you have in order to figure out a missing side length. Okay, so your two special right triangles are an isosceles right triangle, which is we call a 45-45-90 triangle. Okay, the ratio between the side lengths in a 45-45-90 triangle is 1:1 to root 2. Okay, what that means is that the two legs are the same length, right? Isosceles triangle. And the hypotenuse is the length of the leg times root 2. So that's what this x root 2 means in the diagram, and what n root 2 means over in your notes on the right hand side. Okay, so that's the first type of special right triangle. Okay. The second is a scalene right triangle, which is a 30-60-90 triangle. Okay, we call these 45-45-90 and 30-60-90 because those are the three angles in each of those triangles, right? In the isosceles right triangle, it has two 45-degree angles and a 90-degree angle. In the scalene right triangle, there is a 30, a 60, and a 90 degree. Okay, the ratio between the side lengths for a 30-60-90 triangle is 1 to root 3 to 2. Okay, so what that means is if the short leg, for example, is 4, then that means the hypotenuse is 2 times that, which is 8, right? And the long leg is root 3 times that, which basically you would just stick a root 3 on the end of the number that they gave you, right? So this is short leg to long leg to hypotenuse, okay? And the cool thing about these is that it's easy to tell which is which, like where the leg is, where the hypotenuse is, all of that, and which side goes with which ratio, because they're all associated with the angles that are across from them or opposite them, right? So in the 45-45-90 triangle, right, you can see that the two legs are across from the 45-degree angle. You can see in the 30-60-90 triangle, the short leg is across from the 30-degree angle, which is the smallest angle. The medium length leg is across from the medium-sized angle, the 60. Okay, so a good general rule to remember is that if you're reading left to right across the ratio, then what you're going to end up doing is multiplying, just in general, right? And if you're reading from right to left, right, meaning you're going from, say, the hypotenuse to the short leg, you would divide. So if you knew, for example, that the hypotenuse was 10 in this triangle, you would divide by 2 to get the short leg. So, right, 2, divide. Right, I'm going to kind of show you what I mean by that. That's just a little tip, basically, to help you kind of remember when you really need to multiply and when you really need to divide. Okay, so let's look at a couple of examples. Okay. Oh, there's this little thing here about where the ratios come from. I just wanted to show you that these do come from the Pythagorean theorem and our knowledge of both isosceles triangles and of equilateral triangles, right? This is not something that you ever really need to know or be able to like talk about. I just wanted to show you that they didn't just come out of nowhere, right? Like the number, the square root of 2 doesn't come out of nowhere. The number square root of 3 doesn't come out of nowhere, right? Like it's all based on the Pythagorean theorem, okay? So that's why I told you at the beginning that this is basically just a tool that you can use in your right triangle tool belt. But even these problems will work with the Pythagorean theorem if you prefer to use the Pythagorean theorem, right? This is just a way to do problems for these two types of triangles a little bit faster, right? Okay, so here are a few examples for you. Okay, so, oops, I went a little bit too far. So these first two are 45, 45, 90 triangles, okay? So here, this is how I recommend that you do these types of problems, okay? Just to make sure that you're multiplying and dividing and everything's like the ratios are matching correctly and all that fun stuff, okay? First thing is list the name of the triangle. So either 40, 45, 90 or 30, 60, 90. Underneath it, list the side lengths in the picture that correspond or that are opposite, that are opposite, basically that pair with these individual angles. So like this 45, 45, 91 here is A, 3, and B, okay? And then right underneath that, write the ratio, 1 to 1 to root 2. Okay, so now depending on which one of these you want to find, you can write these as fractions, set them equal to each other, and do the cross multiplying, right? So if I wanted to find, actually, I'm going to undo that. Hold on. So if I wanted to find A, I would do A times 1 equals 3 times 1. These have the same ratio underneath them. So they're the same number in the ratio underneath them, so they have to be equal. So A equals 3, okay? Now, if I wanted to find B, that one's a little bit trickier, right? If I set these up in fractions and I do the cross multiplication, I end up with 1 times B, which is just B, equals 3 times root 2, which whenever you're multiplying an integer or a rational number by an irrational number or something inside of a radical, right, you literally are just writing them right next to each other. There's an understood multiplication sign in here, okay? So I'm hoping you can kind of see what I mean when I say take the number that you have if you're reading left to right, right? If you're going this way, if your destination is to find the length of something further on the right, that you end up multiplying by the number associated with that thing that you're trying to find, right? In the ratio. Okay. All right. So here's another one. And I'm going to show you what I mean by the divide, because this is going to go the other way. Okay, so I'm still, though, going to kind of follow the same process. So this is a 45, 45, 90 triangle. I'm going to write my side lengths right underneath that, A, B, and then 8 root 2, because they gave me that one. Okay, and then my ratio, 1 to 1 to root 2. Okay, so I'm actually going to try to find B first, just because it's in my, because it's like already here. Like it's right next to the ones that have numbers on them. Just makes my life a little easier, right? So here, if I write these as fractions and set them equal to each other, see how you have B over 1 equals 8 root 2 over root 2? So the root 2's end up canceling each other out. So see how you end up dividing by the value that's associated with one of these in the ratio, right? Or again, you could do this with doing the cross multiply. You end up with B equals 8, right? So you could do this by doing just straight division because it works in this one, right? Or you could do some cross multiplication, and I'll show you what that looks like in a second in one of these 30, 60, 90 examples, okay? And now I know if B equals 8, then A has to also equal 8, right? So just as a reminder, in order to get this, I did 8 root 2 divided by 8, or divided by root 2. All right, so let's try the 30, 60, 90 ones. Very like exact same process, right? It's just the numbers are a little bit trickier because there's the ratio is different. Okay, so here I'm still going to write 30, 60, 90. I'm going to write the side lengths that are across from those angles underneath each one. So if this is 60, that means this one is 30 in the bottom right corner. So 8 goes under 30, D goes under 60, and E goes under 90. And then I'm going to write my ratio underneath, which is 1 to root 3 to 2. All right. So if I want to figure out what D is, I'm going to end up multiplying by root 3. Okay. And if I want to find out what E is, I'm going to end up multiplying 8 by 2. Right. So here, again, if I write these all as fractions, and remember, this is a ratio, right? So all of those fractions have to be equal. So if I want to know what D is, I end up with D times 1 is 8 root 3, right? And times 1 is just D, right? So you have D equals 8 root 3. Okay, and then if we do a similar thing with the 8 over 1 and the E over 2, right? Again, you end up multiplying, right? 8 times 2 is 16. E times 1 is just E. So you have E equals 8 times 2, which is 16. Okay? All right. These kind of 30, 60, 90 problems are definitely the easiest ones because the number that they gave you is associated with the 1 in the ratio. That always makes your life easier. Okay? But sometimes you're going to come across a problem like this one where the number that they gave you is not across from the 30 degrees, but is across from either the 60 or the 90, which makes your life a little harder, but not that bad. So again, same process, 30, 60, 90. I'm going to write my sides underneath. So y is across from 30. This is 60 right here. So 12 is across from 60. And then x is across from 90. All right, and then underneath, I'm going to write my ratio, 1 to root 3 to 2, okay? And with this one, my life is going to be easier if I write these as fractions, okay? So, because these fractions are equal. So if I want to find y, well, y over 1 is just y, right? And that has to equal 12 over root 3. Now, the problem with this in its current form is that we really don't like to have radicals in the denominator of a fraction. So you have to do something called rationalizing the denominator. The way that you do that is you multiply by the radical on the top and the bottom. So the radical moves to the top, right? So you have 12 root 3, and then on the bottom, you have root 3 times root 3. So that's like root 3 squared. So the square root goes away, okay? And then usually you'll have to do some division here. So like 12 divided by 3, I actually can divide, and that's 4. So your final value for y is 4 root 3, okay? Now that I know this, it's a little easier for me to figure out what x is, right? So if I rewrite this, I'm rewriting it in blue here on the other side. So this is the y fraction. See how you end up with, when you cross multiply, you end up with x times 1, which is just x, and then 2 times 4 root 3, which is exactly what I told you when I said your general rule is that if you're going from left to right across the ratio, which we're going technically from here to here, that you end up multiplying by your numbers in the ratio, right? But just the one associated with the variable you're trying to find, right? So x ends up becoming 2 times 4 root 3, which is 8 root 3, okay? If you're getting a little confused in your own brain with like the multiplying and all of that stuff, like what, which direction am I reading? Which number do I multiply with? Genuinely, I would set up the fractions like this and just do the cross multiplication. A lot of the times you'll be able to do it in your head, but that way you're guaranteed that you'll get the answer right. Okay. All right, you guys. So that is it for this video. If you're feeling confident with this, like I said, this is a very, very small portion of your practice assignment that goes with this section. And it's only there if you're in MYP. If you're in regular geometry, this is like a bonus topic, right? So I do have some extra practice problems for you that I'm going to do in another video that you can watch if you want a little bit more practice or you want me to walk you through a few more examples. But you can just jump right into your practice that's assigned for this section if you're feeling confident about it. All right. So that is it for this video, and I'll see you guys in the next one. Bye, everybody.